Hello, class.
Hello, Professor.
So, we will continue from where we left in our last class. We will learn how to quantify mechanical properties of advanced ceramics. Can you tell me, what are ceramics?
Ceramics is derived from the Greek word keramikos, meaning of pottery or for pottery. From being used in pottery, this group of materials has highly evolved, finding various applications, like being used in insulation, to the human body for orthopedics and dentistry. These materials are present in every household, in form of cutlery, floor tiles, etc., to advanced applications like space shuttles, refractories, etc.
Excellent.
Could you please tell us why this group of materials has such widespread applications?
Ceramics are increasingly becoming a material of choice owing to some of the advantages, like stability at high temperatures, resistance to corrosion, harder than conventional metals and no staining when glazed, etc.
So, how are ceramic materials produced?
One of the most common methods of manufacturing ceramics is by compaction, where a loose powder is pressed to give it a solid. Some advantages of using compaction process are: it can be used for two materials that cannot be mixed. Also, it is possible to manufacture complicated shapes.
So, how do we study this production process? Could you please throw some light on that?
To understand the manufacturing process better, one of the most common methods is to do a computer simulation of the process.
But different materials have different properties. How can we simulate that?
Good question. In computer simulations, we need to feed these mechanical properties to a program. These different properties are treated as inputs for the simulation.
Very interesting. So, what are the methods to quantify these properties?
To tell us about this, Tank, who is a PhD student in University of Belgrade, will join us. Tank, thank you for joining us.
Thank you. Always a pleasure to discuss research with you and your class.
Could you please tell us about your research on how to quantify mechanical properties for advanced ceramic materials?
If you look at how ceramics are manufactured, you will realize that the loose powder becomes a dense solid, and this huge change in state of material makes the quantification a difficult task. This is related to the fact that a powder will have fairly different mechanical properties than a solid. Another thing to note is the fact that different forces will lead to different densities. This effectively implies we need to produce more samples at different densities to study the manufacturing process better. This makes the whole quantification process complicated. Nonetheless, researchers over the years have used different kinds of experiments to overcome these difficulties.
Could you please tell us more about these experiments?
The experiments usually applied to evaluate these properties are Brazilian test. In this test, the sample is loaded along the periphery. The video should make it more clear. Another test that is usually employed is the crush test. In this test, the specimen is loaded along its length. Now, these tests needs to be done for a lot of samples at different densities. Just to give you an example, we need about 40 experiments in total just to quantify two mechanical properties out of the 6 that we are interested in. Another concern is that these tests are destructive in nature. Even though these experimentations lead to satisfactory evaluation of properties, the whole quantification process is tedious and expensive. Thus, it is not very feasible for industrial purpose. Our research aims at overcoming these difficulties for quantification and suggest an alternate, more efficient method. For this purpose, we are using the methodology based on inverse analysis.
Wow, that is so interesting and new. I would really like to know more about these inverse analyses you mentioned. I hope to talk to you in future and learn more about this cool method and your research. Thanks a lot for your time.
You are welcome. I am happy I could tell you in your class about this research.
Whoa, that was so interesting and cool. Thanks a lot for sharing this, Professor.
You are welcome. We will learn about this new method of inverse analysis in our next class. Till then, revise what we learned today.